Hello everyone and welcome back to Express Academy. On this video, we dive back into the world of Linux and LPIC 1. Today I'm going to explain 101.3 topic, which is change run levels and shutdown or reboot system. The weight of this module is 3, which means it needs more of your time. In this module, we learn how to manage the sysv init run level or system deboot targets. This objective includes changing to single user mode, shutdown, or rebooting the system. You should be able to alert users before switching run levels or boot targets and properly terminate processes. This objective also includes setting the default sysv init run level or system deboot target. It also includes awareness of upstart as an alternative to sysv init or systemd. The key knowledge areas are set the default run level or boot target, change between run levels or boot targets including single user mode, shutdown and reboot from the command line, alert users before switching run levels or boot targets or other major system events, properly terminate processes, and awareness of ACP ID. And this is the partial list of used file, terms, or utilities according to Linux Professional Institute website. In our previous video, we explained the sequence of system boot in Linux. In this video, we'll learn how to manage our Linux system services using different service managers. Let's start with sysv. Sysv consists of several executable scripts that run after the init process. You might wonder how we can decide which services should start when the computer boots up. Instead of dealing with the huge text configuration files, we can use something called run levels. Run levels are a concept used in sysv to define different states of the system. Each run level represents a different mode of operation, and each mode dedicates which services and processes should be running. For example, there are run levels for shutting down the system, rebooting, single user mode for maintenance, and multi-user mode with or without networking. A run level is a state of init that defines which system services are operating on your system. Run levels are identified by numbers, each representing a different mode or a state in which your Linux system can operate. They play a crucial role in managing the Linux system. When a Linux system boots up, the first process that starts is init. This process is responsible for running other start scripts, which include initializing your hardware, bringing up the network, and starting the graphical interface. The init process first determines the system's default run level so it can run the appropriate start scripts for that run level. Think of a run level as the state your system enters. For example, if the system is in single user mode, it will be a run level 1, whereas if it's in multi-user mode with a graphical interface, it will be in run level 5. Essentially, a run level is a preset single-digit number that defines the operating state of your Linux or Unix-based system. Each run level represents a different system configuration and allows access to different combination of processes. It's important to note that the specific run level can vary depending on the operating system. The standard Unix kernel supports these 7 different run levels. Run level 0 is the system halt. The system can be safely powered off with no activity. Run level 1 is single user mode or maintenance mode. Run level 2, multi-user mode with no NFS, network file system. Run level 3 is multi-user mode under the command line interface and not under the graphical user interface. Run level 4 is user-defined. On this run level, we as a users can define what should be running. At first it's empty. For example, we could say that Apache HTTP server starts in run level 4. The fifth run level is multi-user mode under GUI or graphical user interface. This is the standard run level for the most Linux-based systems. And number 6 is reboot, which is used to restart the system. And on this table, you can see the difference between Debian and Red Hat based systems. With these two easy ways, you can check run level in your Linux system. You can use run level command and you can use the who command. By default, most of the Linux-based system boots to run level 3 or run level 5. In addition to standard run levels, users can modify the preset run levels or create new ones according to requirement. Run levels 2 and 4 are used for user-defined run levels, and run level 0 and 6 are used for halting and rebooting the system. Obviously, the start scripts for each run level will be different, performing different tasks. These start scripts corresponding to each run level can be found in special files presented under RC subdirectories. At etc/rc.d directory, there will be either a set of files named rc.0 to rc.6 or a set of directories named rc0.d to rc6.d. For example, run level 1 will have its start script either in file etc/rc.d/rc.1 or any files in directory etc/rc.d/rc1.d. Changing the run level in Linux system. Telnet. Telnet is a utility used to change the sysv system run level. Here is how to do it. To check out the run level in which your system is running, you can use the run level command, and I use telninit to change the run level. The second way to change run level in Linux system is init command. Init as a command is a process control initialization like telninit. Init is the program responsible for altering the run level, which can be called using the telninit or init command. For example, to change the system run level to run level 3, you would use the following command: sudo init3. This command will stop all the non-essential services and processes and start all the essential services and processes required for a basic system operation, including network services. For example, to change a run level from 3 to run level 5, which will actually allow the GUI to be started in multi-user mode, the telninit command can be used as sudo telninit5. Telninit vs init command. Telninit is a smaller tool that informs init when it needs to change run levels. So we can use telninit to actually telling init that it needs to switch run level. Telninit is actually linked to init command, and it is possible to use init command instead, but it's not recommended. Setting the default run level in Linux system. etc init tab. In older versions of Linux, we used to modify the file etc init tab. But in modern versions of Linux such as RHEL9 and Ubuntu starting from Ubuntu 15.04, we use systemd as the init system instead of traditional system vinit. Therefore, the etc init tab file is no longer used. After the Linux kernel has booted, the init program reads the etc init tab file to determine the behavior for each run level. Unless the user specifies another value such as a kernel boot parameter, the system will attempt to enter or start the default run level. The default run level is determined from the ID entry in etc init tab. How run levels are set up by default and how they are configured depends in part on the particular distribution you are running. This is the format of each line in init tab file. Here's a description of these fields. ID or identification code, which consists of a sequence of 1 to 4 characters that identifies its function. Run levels, which lists the run levels to which this entry applies. Actions, specific codes in this field tell init how to treat the process. Possible values include init default, sysinit, boot, boot wait, and respawn. The last field is process, which defines the command or script to execute. Remember, etc init tab is being replaced by upstart and systemd, but it's still part of the exam. To view the contents of init tab file, we can use cat command, and as you can see, it says that init tab file is no longer used and systemd uses targets instead of run levels. And it says multi-user.target analogs to run level 3 and graphical.target analogs to run level 5. To view the current default target or run level, we can use systemctl get default. Now we use systemctl command to set the default value of run level. For example, if we want to make our default run level 5, which is used as graphical multi-user mode with networking, we can use the following command. Sudo systemctl set default graphical.target. And if we want to make our default run level 3, which is used as multi-user mode without a graphical interface, we can use the following command. Sudo systemctl set default multi-user.target. It was just a preview for the next lesson, and we will talk more about targets in the next video. Now let's see how sysv implements the concept of run level. etc init.d. etc init.d contains scripts used by the sysv init tools. As we said, in systemv, init program is the first process that is run, and consequently some infrastructure services are started. Files in etc init.d are shell scripts that respond to start, stop, restart, and when supported, reload commands to manage a particular service. But how sysv determine which services inside etc init.b should be started or stopped depend on default run level. etc rc.d. Sysv uses grouping. Scripts of each run level are grouped and placed in etc/rc runlevelnumber.d. As many services might be existed in different run levels, the real script files are held in etc init.d, and etc rc runlevelnumber.d just point to required ones. Let's take a look at rc.5 for example. Each script in each run level is run with its startup or shutdown functions, depending on if that run level is going up or going down. S means starting a script and K shows that it is a killing a script. The sequence of actions is defined by the numbers. Try cat command to see what is inside. And all of these places were places that sysv uses to manage scripts and run levels. In sysv systems, we can manage services with service command and chkconfig command to define how and when services are started. We will talk more about them later. rc.local. But what about etc/rc.local? This file runs after all the other init level scripts have run. So it is safe to put various commands that you want to have issued upon a startup. This is also a good place to place troubleshooting scripts in. But do not forget rc.local may not work properly in Upstart and systemd. Test it, search it, and do the required configuration before using in production environment. And that's it for this video. On the next one, we will talk more about systemd and targets. Hope you enjoyed this video, and if you do, please subscribe and recommend this channel to your friends.